All right, so if we're talking about a radian, we have already seen on Desmos that when we're talking about degrees, we have to switch between degrees and radians on Desmos because they're different units of angle measure. So we're going to figure out what an actual radian is today. So before we do that, I just want to review with you some technicalities from geometry. So if we're talking about an angle is two rays with a common endpoint. One of the sides remains fixed and the other one rotates and moves in order to form the angle, which you're used to seeing. If I were going to draw a picture of an angle, we have our first ray and our second ray. The initial side is going to be that starting side that remains fixed. Because we like fancy extra words in math, so anytime we're talking about the fixed side of the angle, it can also be referred to as the initial side. It's where we're starting. The terminal side is the one that rotates or moves to make the angle bigger or smaller. So if I was looking at the angle that I drew you, the initial side is the one that doesn't move. And remember, they would sometimes show you the measure of the angle by going like this on the inside. So I moved the terminal side counterclockwise from the initial in order to show you how big the actual angle was. So sometimes they'll call it the fixed side, sometimes they'll call it the initial side, sometimes they might say terminal side, or they might just give you the angle, but all of those words just are talking about the different sides of the angle. When we take an angle and we open it counterclockwise, so as it gets bigger counterclockwise, those are positive angle measures. So if we're looking at an angle that opens up, like the one that we said, if we open counterclockwise, that's a positive angle measure. So angles that rotate counterclockwise are positive angles. So counterclockwise, positive. If it rotates clockwise, it's going to be negative. Just so that we can say we know which way the angle is going. So if I'm rotating clockwise, so down from the initial side, that's a negative angle.
And what happens if you have like, so instead of having like the starting would be like this, what happens if you have one where both of them not perfectly fine?
So you could, but what we're going to deal with today, we're only going to have our starting angle be perfectly horizontal, like that. Because we could always just rotate it if we needed it to be horizontal, but to make our lives a little bit easier, we're going to always keep our initial side perfectly horizontal like that today. So clockwise gives us negative. All right, so here's where we're going to actually build ourselves a model of a radian so we can kind of get a better understanding of what it is. We already know that it's a different unit for an angle of measure. So like if I was measuring distance, I could measure it in feet, I could measure it in inches, I could measure it in yards. It's all measuring the same thing, but we're going to get different numbers that represent those measurements because they're different units. So degrees and radians are different ways for us to measure angles. We just want to get a better understanding of what an angle measured in a radian is actually talking about, or what a radian actually is. So you're going to take that pretty pink circle that you have, and the first thing you're going to do is you're going to use your ruler to split the circle into fourths, just like it was on the coordinate grid. So it might be easier if you try and fold the paper, because you'll be able to see the circle a little bit through the paper. The y-axis will be easier for you. The up and down will be the easiest because the circle is perfectly in the center. So you're going to fold it in half. When you go to fold it to get the x-axis, it's not just going to be folding the paper in half because there's a title on the top, so you're going to have to line it up a little bit. But you want to fold it, or just use your ruler to get it so that you have a circle that's split into 4 quadrants. Then you're going to use your pretty colored marker and make sure you can see your x-axis and see your y-axis. So you don't want it just to be like the creases of the paper. You want it to actually have an x-axis on there and a y-axis. Just like you were looking at a circle on a coordinate grid.
What's this string for?
Shall see. All right. So the next thing you're going to do is you're going to make your previous math teachers ever so happy by remembering which quadrant is which.
1, 2, 3, 4.
Yeah! 1, 2, 3, 4. So just so we remember, label that. So just in case it leaves us. We also want to be reminded of the Roman numerals, right? When we're labeling quadrants, we use Roman numerals.
You can write it.
Yes, you're writing that right on your circle.
I wrote it like outside.
All right, so now, ready? Another dazzling moment. The radius of the circle is what? From the center to the edge, right? So you need to take that piece of string and cut it to be the same size as your radius. So you're cutting the string to match your radius. So if I were you, I'd put it right in the center where we have your x, y axis, your origin, right, to the edge, and you're going to cut it to be exactly the same size as your radius. And then the other piece can go in the garbage or go to the side of your desk if it's going to be confusing. You just want to get a piece that's the same size as your radius.
How important is it that it's the same?
We want to be as close to accurate as possible. No, because I did the same thing, and I went like this, but I couldn't get it to cut. And
Yeah,
then all
I
I hear
wouldn't
is
cut either.
boom, yeah.
Scissors.
Safety
It's
scissors.
going in between that board.
I have
It just keeps, mine just comes in.
I got
Ew. Ew, don't ever want it. Alright, so now we've got our circle, we've got our quadrants labeled, we've got a piece of string the size of our radius. Our initial side of our angle is always going to be, we said horizontal, and it's always going to be this part of the x-axis right here. That's always going to be our initial side. And we are going to always start measuring right where our circle, the edge of our circle crosses our x-axis right there. That's going to be our starting point. So if I were you, I would at least label that intersection point of the x-axis and the edge of the circle as your starting point. All right, so now that we've dazzled your previous teachers with your remembering the quadrants and remembering the radius of the circle, here's where we're going to see how good you are at following directions. I'm nervous. Okay, so you're going to take the piece of string that you just cut, and you're going to put one end at the starting point, and you're going to wrap that piece of string around the circumference of the circle as far as you can get it.
And the marker would
And then you're going to use that marker and mark off the end of the string. Which one?
23.
Well, it's not a circle, so.
You're going to wrap it around and mark off where it ends.
And that's a radius. Try to get it, I know that the ribbon kind of curves a little bit. Try to get it as straight or as perfectly along the circumference of the circle as you can. What I did was instead of laying it like flat,
Yeah.
I tilted it
On your on the side makes it easier, right?
So
Yeah. It's easier to kind of get it to curve.
Especially since it already wants to curve.
And then you're going to use your pretty marker and you're going to mark the end of where your string is and label that 1. Then you're going to take your string and you're going to do it all over again. But now you're going to start your string
That's what we do.
at the number 1 and see how far you can get it. And then you're going to mark that number 2. And you're going to keep going until you get all the way back to the start point. But don't go past the start point. So go as far as you can without passing the start point.
regular. You can write it right in regular numbers. That's fine. Yeah, you can write it right. It doesn't matter if you wrote it in Roman numerals. It's okay. You can write it right in regular numbers. Once you've gotten all the way back to the start, without going over, then you're going to start back at the start point and measure backwards, measure clockwise to get the negative angle. Then you're all done. Yep. So you shouldn't end up with more than 6 all the way around. Otherwise you've gone too far. So once, now we're going to do the negatives. So we just traveled counterclockwise, which gave us positive numbers. Now we're going to travel clockwise to get our negative numbers. So you're going to take your piece of string and you're going to start again at your start button, but you're going to wrap it backwards. Yes. And label that backwards -1. So now if you have a different color, I would do it in a separate color just to make, or do it in your pencil just to make it a little bit easier for you to read. Just take my own advice. -1. And you're going to keep going and do the same thing until you get back to the start, but not past the start.
You could have done that.
Oh, man. So now, forward, as we traveled counterclockwise around the circle, we got that radius to fit 6 times, and there was a little bit left over. And when we traveled clockwise or backwards around the circle, same thing. We got 6 times, but a little bit left over. So when we did this, we literally took the radius of the circle and we wrapped it around the circumference of the circle. So if I went in and drew my terminal side of my angle right at this one,
I now have an angle that measures exactly 1 radian. It's as big as the radius wraps around the circle.
Are you doing it?
You can if you want to, but you're not going to need to. We're going to use this circle to answer some questions on your classwork. And then we're going to use what we learned from that in order to start converting between radians and degrees. So we're going to go into your classwork. All right, so we said when we looked at it, we went in and we said that when we start, we're at 0 degrees. We know all the way around the circle. So if I went all the way around, a circle has 360 degrees. That means halfway around is 180 degrees. Half of 180 is 90. And then if I went down to my bottom, I'm going to get 270 because 180 plus 90 gives me 270. But then we also said that if we went halfway around, we had like 3.1 radians, which we said was exactly the same thing as pi. So if I went double, if I went back to 360, I got 2 pi. 90 is half of 180, so 90 would be the half of pi, or pi over 2. And 270 is 3 times bigger than 90, so 270 gives us 3 pi over 2. So we said a radian is the same thing as wrapping the radius of the circle around the circumference to measure an angle. So when we're measuring angles in radians, we're talking about how many pi's we have. We're always going to talk about them in terms of pi because otherwise we're going to have these really giant long decimals, and it just allows us to kind of simplify it and get a more accurate answer versus having to round a decimal that's infinitely many numbers long to 2 decimal places. So what you're going to have to do for the last part of your classwork is it's going to ask you to convert radians and degrees. So we know 180 degrees is equal to pi radians. We just figured that out with our circle. So anytime you're converting, 180 degrees is the same thing as pi. So this is going to make your chemistry senses tingle. You can use a conversion factor of 180 over pi or pi over 180 in order to simplify or convert radians to degrees. So if we wanted to convert 30 degrees to radians, I'm going to take my 30 degrees and I can multiply a number by 1 and not change it, right? So if I know 2 things are equal, if I have my numerator of my fraction and my denominator of my fraction are the same, that fraction equals 1. And I know that pi and 180 degrees are the same thing, right? We said they're equal. So if I multiply 30 degrees by pi over 180, I'm just multiplying it by 1. But it allows me to cancel those degree units and end up just with my degrees in actual radians. Because when I have something that's in the top of my fraction and the bottom, they're going to cancel out. When I multiply straight across, I get 30 pi over 180. And then I'm just going to simplify the numbers in my fraction as much as possible and leave the pi value there. So my zeros are going to cancel out, which gives me 3 pi over 18. And I can simplify that even more. I can say, okay, I can divide both of those by 3, right? And I get 1 pi over 6. So 30 degrees is exactly the same thing as pi over 6 radians. So that last part of your classwork is going to give you a degree value and ask you to convert it. And it's going to actually give you like fill in the blanks to even type in the conversion, to simplify it. It's going to give you all the steps to go through and do that. It's also going to ask you to convert something like pi over 2 radians to degrees. So the only difference is if you're going backwards, your conversion factor is going to flip. So whatever you're trying to get rid of is always going to be in your denominator. So since we're taking pi over 2 and we want it to be degrees, I want to get rid of the pi because the pi should only be there if I'm talking radians. So I'm going to multiply by 180 degrees over pi, because then I have a pi in my numerator, I have a pi in my denominator, they're going to cancel out and go away. And I'm left with 180 degrees over 2, which is just 90 degrees. So that's your last part of your classwork for today, is to go in and just do those conversions. Okay?